Hello everyone, welcome back to this channel. In the previous videos, we have solved two problems, two-sum problem and the three-sum problem using same pattern. In today's video, we are going to solve another problem, the four-sum problem, but we will not be directly jumping onto the optimal solution. We will be discussing it step by step. Firstly, we will discuss the brute force approach and then we will move towards the better approach. And finally, we will come up with an optimal pattern-based solution. The goal is not just to solve this four-sum problem as another problem, but we have to understand that how the optimizations evolve from one approach to another approach. So let's just discuss it step by step, and we will see how easy it is if we have already a good understanding of the two-sum problem and three-sum problem. So let's just discuss it. Firstly, let's read the problem statement. The problem statement is we are given with an integer array nums and we are having an integer target. And we have to find all the unique quadruplets. Quadruplets means the set of four elements which are summing up to a particular target. And whatever the indexes will be, that indexes must be unique. They should be different from each other. So this particular set of four elements, when they are summed up, they should give this particular target, whatever it is given to us as an input. And the solution set must not contain the duplicate quadruplets, as we have already seen in the two-sum problem and three-sum problem as well. So uniqueness is defined by the values, not by the indices. So this particular problem statement is simple, and that we are given with our input array. Our example we will be considering in this particular problem. And for that input array, we will be given with a target. We have to check all the particular quadruplets, or we have to get those quadruplets as a result, whatever sum up to give that particular target. So whatever the indexes will be, those should be different. And also one point is mentioned here that the uniqueness of the quadruplets is defined by values. The values must be distinct, the values must be different in that. And like I already explained in the previous example, the previous problem as well, that there can be the values from the different indices, but if those values are same, or let's say the order of those numbers inside that particular quadruplet is just different in the different quadruplets, so we do not have to consider those, because if they are of the same values but coming from the different indices, that is not the point that they are from the different indices, but because they are having the same value, so they are the duplicate quadruplets. So we have to check by values, not by the indices, because there can be multiple quadruplets present inside the input array, which are coming means the values which are coming from the different indices, but they are the same values. So that we have to consider here. So this is the problem statement, and now let's just look at the example so that we can have a more clarity on this. So this is the example I have taken. This is a good example in order to understand this problem. So this is the input array, and we are given with a particular target. That target is 0. We have to find for the uh, set of four elements, or I can say the quadruplets, which give the target as 0. So the target mentioned in this particular input is 0. And now let's just see this example. So here we can see the multiple quadruplets can be formed which are giving this target 0. Like this 1, -2, -1 and 2. When they are added up, they are giving the sum 0, which is equal to the target. So this is one quadruplet. Now these are the indices I have mentioned here, that for these particular different indices, this same quadruplet is coming. For example, we can see from these indices 1, 3, 0, 4. So this is one index, this is third index, this is zeroth index, and this is fourth index. So we can see that whenever these numbers are summed up, they are giving the sum 0. In the same way, just instead of this third index, at the third index there is -1, and also we can see at fifth index. At fifth index is also the value -1 is there. So the different index is there, but the value is same, as already mentioned in the problem. So therefore, these two quadruplets from the different indices are similar. Again, we can see from here 1, 3, 6, 4. So this is one index, this is third index, this is sixth index, and this is fourth index. So again, when these are summed up, they are giving the result 0. And also for this particular indexes as well. So we can see here that 6 groups are formed for these quadruplets. Means how this every group is telling about one quadruplet, which are coming from the different indices. For example, this quadruplet is coming from all these indices. Means the set of these four indices again, then from set of these four indices, then from set of these four indices. So this particular quadruplet is similar for all these indices. So we will just consider it as a unique one, and we want this quadruplet as one only, not the four quadruplets as it is mentioned here. Again, we can see this particular quadruplet is coming from these two set of indices. So again, this is this quadruplet will come two times. So we only want this one inside the output. And this particular quadruplet is coming only from one set of indices, so it is unique in itself. and as particular as this quadruplet is also coming from these four set of indices, these four set. So we only want the one unique quadruplet like this, not four. And these two quadruplets are also mentioned here. This particular quadruplet is coming only from one set of indices. This quadruplet is coming from two set of indices. So we can see here the quadruplets, the six groups are formed for these quadruplets. So in total, if we count these, like 4 and 4, 8, these are, and 10, 11, 12, 13, 14. So total 14 quadruplets are formed out of this input array. But how many quadruplets will be the unique ones? We have formed the six groups of quadruplets which are coming from the different indices. So therefore, six unique quadruplets will be there, which should come as the output. And that will only come when we will be handling the duplicates, as we have learned in the previous problems in the 2 sum and 3 sum as well. So we have to get an idea, we have to get an intuition that how we can handle the duplicates, so that the quadruplets which is coming 4 times, it should come only for 1 time. The quadruplet which is coming for 2 times, it should come only for 1 time. So therefore we have to check that how we can handle the duplicates, which is a core part of this problem. So this is the example we have seen, that 6 groups of the quadruplets is formed, out of which out of the total 14 quadruplets, only 6 will be the unique ones. Okay, so this is the example all about, and now let's discuss the approaches that how we can solve this problem, and step by step we will move with the implementation and also with the time complexity and space complexity trade-offs. So this is example we have seen. Now let's get to the approaches. So the very straightforward idea which we can think of in order to solve this, like just imagine that we don't know how to solve this problem. What can be the simplest idea we can use in order to find all the quadruplets? Like I'm not considering any of the, like I'm not considering the handling of duplicates as of now. I'm just saying that how we can find all the quadruplets which can sum up to this result, means which can be equal to the target. So I can simply say is I can try out all the possible quadruplets in this input array, as we did in the 2 sum and 3 sum problem as well. So how we can get all the quadruplets? We can just use for loops, means in the implementation part, we can just use for loops in which we will be fixing every value. Like first value we can fix here, second value we can fix here, third value we can fix here, and fourth value we can fix here. And every time we will just take the sum of those values, and we will check with the target if it is equal to the target or not. And once we get that, okay, this particular set of 4 elements or the quadruplet is equal to the target, then we can put it inside our result in whatever form we have to return it. So this is the simple idea, or the straightforward idea we can use to just try out all the possible quadruplets. So let's just check with this example how we can do that. So we can just use for loops where one index I can use for the first value, second index for the third value, for the second value, third index for the third value, and fourth, this, let's say L is the index for the fourth value. So once we have set all these values, or fix all these values, we can just take the sum of those, and we can check if it is equal to the target or not. And once we get it, we can store inside our results. So this is the very simple implementation. We should just directly get into the implementation and implement it, and then we will understand the analyze the time and space complexity for it, and further how to optimize it. So this is the function which we have to complete. Now let me just take the size of this nums. So n equal to nums dot size, and once we get the size, we can just fix these values for int I equal to 0, I less than n, I plus plus, and this is for fixing the first value. And once it is done, we can then fix for the second value. So for int j equal to, now j will be starting from, the j index should be greater than I, and first of all, whenever it will be started, it will be started from I plus 1. So j equal to I plus 1, j less than n, and j plus plus. And then third value, that particular index will be, means k index will be greater than j. First of all, it will start from j plus 1. So for int k equal to j plus 1, k less than n, k plus plus. And then for the fourth value, so again this, let's say this is L, which will be greater than L, which will be greater than k. So this should be start from k plus 1, well equal to k plus 1, and L less than n is L plus plus. So this is how we have fixed all the values. Now we will just take the sum explicitly. So int sum equal to this nums of I, nums of j plus nums of k plus nums of L. So this is how we can just get the sum, and at the end we can just check if it is equal to the target or not. So we are considering that target is equal to 0. So whenever the sum of these four elements, or any of the set of four elements, when that sum, if it that sum is equal to 0, then that will be equal to the target, and in that case we have to just come and store it inside a resultant vector. So what I am doing is, I am just taking a vector of vector int, because we have to store the quadruplets inside that vector of vector int, and let me just name it as result. So whenever I get a sum equal to the target, I can just take that result and push that quadruplet. Okay, and that will be nums of I. So let me just take this here, and okay, so I can just write nums of I, comma nums of j, comma nums of k, comma nums of l. This is how I can get this inside the result whenever I get the sum equal to the target. At the end, what I have to do is I have to just return that result. So I can just come here and I can return the result. So whatever the quadruplets will be there out of this input array, that will be coming in the result. So let me just take this input here. What is the size of it? The size is 8. And what are the elements? 1, -2, 0, 1, -2, 0, -1, 2, -1, 1, 0, 1, 0, and we have to get the target of 0 from the quadruplets. So let's just perform a run here. Let's see what the output will come. How many number of quadruplets are coming? Okay, so we can see from here that how many quadruplets came. So let's just count these. So we can see from here 14 quadruplets came, which we have already seen in the example when we were discussing it. So 14 quadruplets are there, which are means a set of four elements which are summing up in order to give that sum 0 as equal to the target. Now we can see here what are the duplicate quadruplets we have already seen in the example. So let me just take you here. We have already seen that there will be 6 groups will be formed, and each group there will be some of the duplicate quadruplets. So like this -2, -1, 1, 2, it is present 4 times coming from the different indices. Likewise, -1, -1, 0, 2, it is coming from 2 set of indices. So this is how these 14 quadruplets are coming, but they are not the unique ones. They are all the quadruplets coming. But we have to handle those uh, duplicates. Now again, in order to handle the duplicates, we will be using the set as we did in the threesome problem. We know that the set is having the property that it is holding only the unique things. Okay, so whenever any of the duplicate quadruplet will come, it will just reject it and store only the unique quadruplets. So for that, instead of this result, I will be using the set here. So let me just use set in this case. So set, and it will be storing vector of int. Okay, and let me just name it as set. And see, now whenever this any of the sum of the set of four elements, whenever they are summed up and getting the sum equal to 0, which is equal to the target, so we do not have to directly get into the set. Firstly, what we will do, we will just take a kind of vector, we can say, and let me just name it as quadruplet. And this, whenever the numbers are coming which are summing up to the target, I can just take all those numbers as in the vector. So that will be nums of I. Okay, or I can just write in the form. I can just take all these values, put it inside the vector. These will be stored here. So these all are the values, the four values which are summing up in order to give the target 0. And once we have stored them inside the vector, now we will sort this vector. So sort quadruplet dot begin, comma quadruplet dot end. Okay, and once it is sorted, now why we have sorted it? Because in order to normalize them, means in order to make them in the sorted order. So let's suppose that this particular let's say this -2, -1, 1, 2, this particular quadruplet came, and let's say this is an unsorted form, like in any of the form. And once we sort it, now like this means whenever any quadruplet comes which is duplicate of it, that will also be sorted. So whenever then that same sorted or that same normalized quadruplet is going inside the set, it can easily check that okay, this is a duplicate one, so I can reject it. So that's how we are sorting this and normalizing that particular quadruplet, and then we can take this set and insert this quadruplet. So set dot, with the help of insert function, we can take this quadruplet and insert in it. So whenever any new unique or any different quadruplet is coming, that will be only inserted inside the set, not the duplicate one. So this we have done. Let's again perform a run here, and now we will just see that only 6 quadruplets will be there, which will be coming in the output, because they are the unique ones, not the duplicate ones. Okay, so here what we have to do, we have to return this set, because the result is present inside the set. So this will be in the form of vector of vector int, and that set will be taken, that is set dot begin, comma set dot end. So this is going to give us the result, the 6 unique quadruplets. So after running this, we will get the 6 quadruplets, which are the unique ones. Okay, so we can see the 6 unique quadruplets are there, like -1, -2, -1, 1, 2. We can also check from here, -2, -1, 1, 2. This is one quadruplet. -2, 0, 0, 2 is another quadruplet. -2, 0, 0, 2 this one, and -2, 0, 1, 1. So -2, 0, 1, 1 is this quadruplet. -1, -1, 0, 2. So this is -1, -1, 0, 2 is this quadruplet, and -1, -1, 1, 1. So this is one, and -1, 0, 0, 1 is this quadruplet. So we can see 6 unique quadruplets are present after implementing this brute force approach. Now see, this brute force approach is good in order to understand this problem, but we can see here this is very much inefficient. Like we can see, we have to use for loops in order to get each and every quadruplet, in order to try out all the possible the quadruplets. So we can see the time complexity is going to O of n power 4. Now see, we can see here for loops are used here, so because of which O of n power 4 will be the time complexity, like O of n power 4, that kind of operations we can see. Now inside this, you may see that okay, we are also sorting here, so it might take n log n kind of complexity, but no, because we are sorting the quadruplet every time, we are not having any of the array or any of the like array of different size. Every time we are having a quadruplet means the 4 elements. So we know that every time the 4 elements will be sorted, any of the 4 elements, so that size of sorting that particular part is constant. So if we consider that k number of elements are there which we have to sort every time, that is a constant number. So here that k value is 4. So now if you take that 4 log n, like 4 log 4, that will be a kind of value 8, which is again in itself a constant. So whenever we are sorting here at this quadruplet, that is taking the constant time, because the numbers are fixed every time. That size of the numbers is not differing. So therefore, for sorting O of 1, that is the constant time will be taken, not any n log n kind of or k log k. So sorting is taking constant here. Okay, and now if we talk about this set, so like insertion cost will be taken in order to insert these quadruplets. So there can be, just let's consider the k quadruplets are there. Like we don't know that every time whenever the input will be input will vary. So in that case, the number of quadruplets which are getting inserted in this set, that will differ. So let's consider that number is k. So insertion cost which is taken inside, like in order to insert that quadruplet inside the set, that will be log k. So that is depending on the output, that whatever the number of quadruplets are getting inserted, so that depends on the output, and that will not be counted inside the time complexity analysis. So overall, if we see the time complexity which is of this for this particular brute force approach, that is O of n power 4, because of these 4 loops, and for this sorting, that is constant. Okay, and whatever this insertion cost is there, log k, that will be depending on the output. So that is not counted in the time complexity. So just the overall will be O of n power 4 time complexity. Okay, and now talking about the space complexity. So in the space complexity, this set is used in order to return the output, like whatever the quadruplets are coming, that will be stored in this set, and that this set will be returned as the output. So that is not counted inside the space complexity, because that is part of the output. No any auxiliary space is used in order to solve this problem. So here the space complexity will be constant. So for the brute force implementation, the brute force approach, we have seen the time complexity is O of n power 4, and the space complexity is constant in this case. So we have seen that this particular approach is very much inefficient. So we must come up with a better approach. So let's just try out the better approach, that how we can optimize this approach. So for this, let me just take this this example, same example, and let me just remove this, and let's now discuss the another approach. So this, see, already we have seen in the threesome problem as well, whenever we are having this kind of like time complexity like O of n power 4. Now we will look for some approach which can like maybe we can think of reducing a part of one loop out of these 4 loops. We can do the work in the 3 loops also, like there can be some of the approach. So that will be like, we can, what we can do is, as we did in the threesome problem, that we have fixed one value and then we have converted that problem from threesome to two-sum problem. Now again we can think of that same idea here as well, that we can fix one value and then we can say that okay, inside one loop we can solve it as a threesome problem. And if we go deep into that, then we can again fix one another loop inside that as well, and we can convert it into a two-sum problem for that. So what is the conclusion, what is the idea, the intuition behind this? That we can fix two values and then we can convert this problem entirely into a two-sum problem, and we can solve them that accordingly based on the two-sum problem, like two-sum problem using hashing. So what the idea is, that we can just fix the two values. Let's say I have fixed this value and I have fixed this particular value. So now two values I have fixed, like with the help of two loops, and inside that two loops now we will be solving it as a two-sum problem using hashing. So once we have fixed these two values, now this particular part is remaining for which we have to solve, and this we can solve using the two-sum, like a kind of two-sum problem using hashing. So what we can do is, let's just perform a dry run on this and then we will come to the implementation. So let me just take this, and for this what we will need is, we will need a set here in order to check for the existence of the values which we will be solving for the two-sum problem. So let's just take it as set 2, and the same set means another set we will have to take in order to put our result. So this will be the set 1, let me call it. So this will be storing the results. Okay, so now we have already fixed these two values. Now we will take this another value here with the help of let's say k index, and after this, now see what we are doing is, we are applying this particular two-sum problem in this rest of the part. So let me just take it as this. So on this we are applying the two-sum approach, and what will be the target in this case? See, we are already having the target as 0, and for this two-sum problem, what will be the target? That will be 0 minus this value and minus this value first of all. So 0 minus 1 minus minus 2, that will be 0 minus 1 and minus of minus 2. So this will be the target, and that will be minus 1 plus 2, that will be 1. So this is the new target which we want from in this particular problem, as we are solving it like a two-sum problem. So the target is 1 here, and now we have to check for the particular pairs which can give me this target 1. So again we will be now, and what happens in the hashing when we apply on the two-sum, we take this value, and whatever the target we are having for this particular part, we just take target minus this, and if that value is existing inside this particular array in some of the part, that we will be checking with the help of set 2. So if it is available, then we get to know that okay, one value is this, one value is this, another value we got is this, and another means last value is the need which we were checking for. So right now we are having this 0 value. Now what will be the value which we are checking for? That will be target minus this value, so that is 1 minus 0. Now we are checking for 1, but 1 is not present inside the set. So what we can just do is, we can just take this value and put it inside the set. So this will be now having 2, sorry, this will now have 0, and now what will happen is, this k will move ahead. This k moves ahead and it will now check minus 1. Now for minus 1, what will be the value we will be checking for? That will be 1 minus minus 1, that will be 2. So we are checking for 2, but 2 is not available inside the set. What we can do, this we will take this minus 1 and put it inside the set 2. This will be minus 1. Now this k moves ahead. Now it will check for what need, that will be target minus this value. So 1 minus 2, that is minus 1. Now have we seen minus 1 inside the set? So yes, we have seen minus 1 in the set. So therefore this value which we have fixed, these two values, minus this 1 minus 2 and this current value 2, and the minus 1 value which we are checking for inside the set, and that was we are saying that that is already present inside this particular array in this part. So therefore what will be the quadruplet formed? 1 minus 2, 2 minus 1. This one will be the quadruplet. So let's just put it inside this set 1. That will be 1 minus 2 and 2 and this is -1, which is already present inside the set 2, means inside the array in any of the index. So this is one quadruplet we have found till now. Okay, now what will happen is this k will move again ahead. So now it will check -1. Now 1 minus -1. Okay, we also do have to one thing, we have to put this 2 inside this set. Okay, so we have inserted this 2 inside the set 2. Now this k moves ahead, so this is -1, and now it will check for 1 minus -1, that is 2. So have we seen this inside the set? So yes, we have seen this 2 inside the set. So therefore the another quadruplet which is formed, that is 1 minus 2, and this -1, and this another 2. So this is another quadruplet. Okay, so now it will check for the duplicacy. So we can see here this 1 minus 2, -1, and this 2 is already present inside the set 1. We can see here that this particular quadruplet is the duplicate one, which is already present inside the set 1. So it will not be storing the duplicate quadruplet, it will just reject it. So this 1 minus 2, 1 minus 1, 2, this is a duplicate one, it will not be get inserted inside the set 1. So therefore this one, okay, now this -1 will be stored inside the set 2. Okay, so we can see here -1 is already stored inside the set, so therefore no another -1 will be going. Now this k will move ahead, and it will now see a 1. So 1 minus 1 is 0. Have we seen this 0 inside the set? So yes, we have seen. Therefore another quadruplet is 1 minus 2, 1 and 0. So that will be 1 minus 2, 1 and 0. Okay, so we can see from here that the sum in this particular quadruplet is also giving the sum 0. Okay, and now this 1 will move ahead. So inside this set 2, it will be inserted. Now this k will move ahead, and it will see a 0. So 1 minus 0, that is 1. Have we seen this inside the set 2? Yes, we have seen inside the set. So therefore the another quadruplet is 1 minus 2, this 0, and this 1. So again this same quadruplet is already present inside the set 2, so that will not be inserted. Okay, so when this k moves ahead, and now this particular loop will be ended. So for these two fixed values I and j, k has started from here, and it has solved this particular part as the part of do some problem using hashing. And now this particular j will move ahead, and then again k will start from here, and it will check for another quadruplets, whatever will be formed. So this is how this approach is going to work, and already we have seen this how it is going to work in the threesome problem as well, and also in the foursome problem. Now we will be implementing this, that how we can write it in the form of 3 loops and solve it with the help of hashing. So let's just remove this output from here, and let me just go into the approach 2. Here again we will have to get the size of this nums, that is nums.size. Okay, so now I will be taking the set here. So one set will be in order to store the results, the quadruplets, the final result. So those will be of type vector. Okay, those quadruplets, so that will be vector int, and let me just name it as set 1. Now once it is done, I will be using the loop for int I equal to 0 and I less than n and I plus plus, and okay, now this has fixed one value, and then I will be fixing the another value. So that will start from I plus 1. So that is j equal to I plus 1, and j less than n and j plus plus. So this has fixed another value, and now inside these two loops, now we will be solving as the part of two-sum problem using hashing, where what has to be done is we just have to take another set that will be storing the integers, which because we have to check for the existence, that is set of integer, and let me just name it as set 2. And now I will be using another loop. This loop is a part of two-sum problem. Okay, means which we are solving for the rest of the part as two-sum. So that is for int k equal to, and that will be starting from j plus 1. So j plus 1 and k less than n. This is k plus plus. So for this, what we have to do is, whenever we are having any value like k value, what we have done, whatever the target we are having, we take target minus that value and we check inside the set. So now we are already having two fixed values. So what was the new target we are having? Target minus this first value and minus second value. That was the newer target for this. And again inside this as well, we have to whatever the value we are traversing, that also we have to exclude from the target, so that we can get the need, means whatever the value we want in order to complete the quadruplet, which can sum up to 0. So what we have to do is we just have a need variable in which we will take the target minus nums of I minus nums of j and this is minus nums of key. So this will be a need that we will be checking inside the uh, set 2. Okay, so this is a kind of like in the way which I have explained, that this is our two sum problem, and then we are checking for this target. So this is in that way, in the two sum problem, in the two sum way. But as we are solving for the four sum problem, so the implementation somewhat changes, like in this way. Whatever the target we are having, then we excluded the two fixed values, so that created the target for this two sum problem, and then we are subtracting this value. So for that we are now checking for the in the now checking for that need inside the set 2. So we will just put a condition here that if this set 2, inside set 2 we have to find, so using the find function we will be checking for the need, and this will be like set 2 dot end. Okay, so if we get that particular need, then what we will do, as we did already, we will take a vector here, and inside that vector, like let me just name it as quadruplet. We will just store this. What we have to store, see, whatever the nums of I, nums of j we are having as the fixed values, and whatever the value we are traversing right now with the help of key, that is nums of key, and the need which we are checking for, if that need exists inside the set, therefore that is available somewhere inside the array in that part, so that need will be the fourth value. So the value which will be the, sorry, the vector which will be formed, that will be of nums of I comma nums of j comma nums of k, and okay, that will be the fourth value will be the need. And once we did this, we will now sort this. So sorting this quadruplet dot begin, starting from beginning, comma quadruplet dot end till the end. Once we sort this, and then we will just take this set 1 and we will insert this quadruplet into it. So this is the insert. With the help of insert function, we will take this quadruplet and insert in it. Okay, now we did this. Every time what we have to do is, whatever this nums of k we are traversing or checking, we have to put it inside the set 2. Okay, so we will just take this set 2 and we will insert this nums of k, that will be inserted inside the set 2. So this we have done, and now at the end what we have to do, we just have to return this set 1. So that will be in the form of vector int. So that will be vector of vector int, and what we have to return, that is a set. So set 1 dot begin comma set 1 dot end. So now this particular set 1 will be giving the output. Whatever the result is stored inside the set 1, that will be returned. So this is we have done. We have just used two loops in order to fix the two values, and then this problem is converted from four sum to two sum. Or we can say in the another way, that this, after inside this one loop, we are solving it as a three sum problem. That is the different things, the different ways we can see. So just we have solved in the simpler way, which we have already done in the previous problem as well. So let's just perform a run here, and then we will check for the time and space complexities of this approach. Okay, so we can see here, with the help of hashing approach, this approach is handling the duplicates. Why? Because we are using a set. Till now in these two approaches, what we just saw is that we are not doing anything extra or anything smartly in order to handle the duplicates. We are just relying on the set in order to clean those duplicates. Whenever they are coming inside the set, they are just seeing that, okay, if I have not encountered such quadruplet, I will just insert it, otherwise I will reject it. So we are just relying on the set. Otherwise we are not doing anything extra here. We are just using the loops and then finding the duplicates, like quadruplets, and inserting inside the set, and then set are responsible in order to clean those duplicates, that duplicate quadruplets. Okay, so now let's talk about the time and space complexity for this particular approach, and then we will move further with the optimized approach as well. So here we can see that three loops are used here. Two loops are in order to fix for the two values, and one loop is used as part of the two sum problem after reducing it. So we can see here a kind of n cube time complexity is coming. But again, inside this third loop, we can see the sorting is done for the four elements. That is constant in itself, as I already told. And this set 1 is used in order to give the output. In order, means the quadruplets which are stored inside this set 1, that is the part of output. That is not counted inside the time complexity analysis. And yes, but the set 2 is used in order to insert this values. Means we can see for every j iteration, this hashing is done. And that will be for kind of n elements, we can see. So the insertion cost which is taken by the set 2, that will be O of log n, we can say. So the overall time complexity will be O of n, like O of n cube log n. So that will be the time complexity. And now talking about the space complexity. So again, this set is used in order to return the return in the form of output. So that will not be counted in space complexity. But this set 2, which is used in order to store the results, store the values for the existence check, that we can say as O of n. So that is the extra space only needed in this, the kind of auxiliary space extra from the input out, apart from the input or output. So that the overall we can see the time complexity is O of n cube log n, and the space complexity is O of n, the extra space which is required by set 2. So this is the approach. Again, this is better than the this brute force approach, but again it is using the memory. Means in terms of time complexity, we can see it reduced from O of n power 4 to O of n cube log n, but it is using the memory here. So that is not efficient in the terms of space. So we will have to move towards a better approach so that we can get a better time and space complexities. So let's just get into that approach and understand how we can use it. Let me just take this array here from here. So I will just take it here. And okay, so this is the another approach which we are now discussing, that is the two pointer approach, the two pointer plus sorting approach, which we already discussed in the threesome problem as well. So now what we are doing here is, as we did in the threesome problem, that we fixed one value and then we were checking for the rest of the part. Like we have solved the rest of the part as part of the twosome problem using two pointers. Now in this particular foursome problem, we are now going to fix two values, and for the rest of the part, we will be solving as a part of twosome problem using two pointers. So this is the same thing. There we have fixed one value, and now we are fixing two values. So let's just firstly sort this particular array, and then only we will move to forward. Means why we have to sort it? We have to sort this in order to normalize the numbers. Like those all the duplicates numbers, those all the duplicate values will be grouped together, so that after that, whenever we are performing the pointer movements, that becomes very simple, because after sorting itself we can apply the two pointer approach here, and that will work. So let's just sort it firstly. So this is the sorted version of this particular input. This is the original input and this is the sorted one. Okay, so right here, this is the sorted nums. Now what we have to do is, we have to just fix two values. So let's just come here and we will just fix two values. This is with the help of I index, and this is with the help of J index. We have fixed two values, and now this particular part is left, and this we have to solve as a twosome problem. So what we will now do here is, this is our left pointer, we will call it. This we will give it as a left pointer which is pointing, and at the end index the right pointer will be pointing. So now initially what was the target we are given with? We are given with the target 0. Okay, now I have to mention one thing here is that in the last video also, when I was solving the threesome problem, I have implemented I have explained the conceptual version in the different way and implemented in a different way, and both versions were correct, but I have just added the text version so that the confusion should not be there. But in this video, I'm just I am taking some time in order to explain, in order to clarify that particular part. So what I'm saying is, if I'm having this particular target, we are having this original target, and now I'm checking, I'm just solving it in a form of twosome and for this rest of the part. So I'm taking a new target. How? This target minus this two fixed values. So target minus nums of I minus nums of j. Now that is the new target which I'm looking for inside this part, and that target will be given by nums of left plus nums of right. So what is the point? The nums of left will be like nums of left plus nums of right, nums of left plus nums of right, that will be equal to nums of I, sorry, not nums of I, that will be equal to target minus nums of I minus nums of j. Okay, so this is the point. Means whatever the target minus nums of I minus nums of j target, the new target is coming, that should come from nums of left plus nums of right. So these both are equal. Now if we again if we try to solve this, what it will look like, it will be like target equal to, like if we just leave the target at the right hand side, so we can just have this nums of left. Okay, that will be nums of left plus nums of right plus this minus nums of I and minus nums of j can come here, so that will be nums of I plus nums of j. And what it will be equal to, that will be equal to the target. So these are just the two versions in which one we have used and not when we have just took the new target and then we were checking for the rest of the part, like in the conceptually when we are understanding. And this second part is like having the all the sum of all the four numbers and then checking equal to the target. Just the difference is that here we are understanding in this way by having the newer target, but in the implementation we are not using it as a new target for the, or we can say for the reduced target. We are just having the sum of all the four variables and then checking equal to the target or not. So the thing is simple. One is easier in order to understand, like in this way by having the reduced target, and one is in order to the easy in order to implement, like having the sum of all the four variables and then checking equal to the target. So it is very simple. It is not different. These both are not different. Just what we have to do is we just take the sum of all the four variables, and if it is like if it is going too large, then we just move the left the right pointer back. If it is going too low, means if it is very small, the target, the value which is coming after the sum, if it is too small, left pointer ahead. And if it is equal to the target, then we just take that particular quadruplet into the consideration. That's all for which I want to make the clarity in this particular section. Okay, so now we have seen this particular thing. So let's just understand it and perform a dry run. Let me just move it here. Okay, now this is the left pointer and this is the right pointer. Now what we have to do is, what we are having the target minus this, means target minus nums of I minus nums of j. Now we have to check for the target 3, means we will be taking the sum and then checking if it is equal to the target or not, if it is less or if it is greater. So we will just take the sum here, and we are seeing that the sum is minus 1 plus 2, that is 1. So it is less than the target. It means what we have to do, we have to move this left pointer ahead. Okay, now 0 plus 2, it is again 2, which is less than the 3, so it is less than the target. Now we again have to move this left pointer ahead. 0 plus 2 this 0 plus 2 is again 2, less than the target, so we again have to move this left pointer ahead. Now 1 plus 2, this is equal to 3. It means we have got a particular pair from this by 2 sum, that this particular pair is giving us the target 3. And yes, now we will, when we take the sum of all these, like nums of I, nums of j, nums of left, nums of right, that will be equal to 0, which we want as the original target. So that will be one quadruplet which we have found. So this is how we have to see. Again, we can see in the, like in the implementation as well, which as I have just explained, you can also see in that sense. So let's just again take this left and right pointer. So this is left, and now we will be just taking the target directly equal to 0. We will not be removing these fixed values. Okay, so what will be the values? Minus 2, minus 1, minus 1. That will be minus 4. And one value is 2. So minus 4 plus 2, that is minus 2. Now it is less than the target. So yes, this is less than the target. Therefore, we must move this left pointer ahead. So we can move this left pointer ahead and it will now come to this third index. This is having the value 0. Now again, we will take the sum. So minus 2 minus 1, that will be minus 3 plus 2, that is minus 1. Again, it is less than the target. We will move this left pointer ahead. Now again, it is 0. So again, it will come minus 1, which is again less than the target. So we will also have to move this left pointer again. So this is now 1. So 1 and 1, these are cancelled. 2 and 2 are cancelled. Therefore, it is equal to the target. Now this is a quadruplet. So I have already told you that these both are same approaches. One is easier to understand and one is easier to implement. Simple. Like both are derived by each other, like this we can understand. So this is the approach. And then now whatever already I have explained in the threesome problem as well, I will just attach in the I button and also inside the description, so that the detailed explanation of this you can also see there. And yes, the whatever the required I have just explained in this. Now let's just get into the implementation and implement it. Okay. So this is the approach, and let me just remove this output. Now I will be taking the output size, that is n equal to nums dot size here. And after this, what we have to do, I will be just sorting this. I'm sorry, nums dot begin, comma nums dot end. I have just sorted this entire array, and now I will be using the two loops in order to fix the values. For int I equal to 0, I less than what I have said in the threesome problem. We want at least 2 values after that last value. And in this foursome problem, we want at least 3 values after that last value. So n minus 1, n minus 2, n minus 3, n minus 4. that will be less than n minus 3. Okay, so n minus 3, this is I plus plus, and for another value that will be for int j equal to, that will be starting from I plus 1, and this is j less than n, and this is j plus plus. Okay. Now in the threesome problem, what we did was, we also have to see one thing I have missed, also explained in the previous problem. We have to check for the different fixed values. The fixed values must not be same for the next iteration, because if they are same, then we are going to search in the same search space. So we have to check for both the indices. For this as well, in this we will just put a condition if I is greater than 0, means for this we are starting from 0. So firstly it should be greater than 0, and then only we will check if nums of I is equal to this nums of I minus 1. And if it is the same fixed value, we will just continue for that iteration. We will not be checking. We will just continue in this case. Okay. And also, as we are doing in this particular second loop, so also we have to put here that same condition as well. That this, first of all, this j must be greater than what? See, it is starting from I plus 1. Now we do not have to have the absolute value. We have to have the relative value, means from where it is starting. It is starting from I plus 1. So first of all, j must be greater than I plus 1. And if it is the condition, means if it is correct, then we can check for nums of j equal to nums of j minus 1. And if it is the case, then again we will continue in this case. We do not have to have the same fixed value. And once it is checked, now we will use the 2 pointers. So we can just take the 2 pointers. One is at the left, just pointing at what? It will be pointing at j plus 1. Okay. And another will be pointing at that is the right pointer, that will be pointing at the n minus 1 last index. Okay. And now we will be using the while loop where the left will be less than right. Okay. And here now we will just have the sum. So int sum, that will be equal to, now we are implementing now, so we can just use the easier thing, that is having the sum of all the 4 values, that is nums of I plus nums of j plus nums of k, nums of k, that will be nums of left, and this will be nums of right. This will be nums of right. This we have taken. Now we will just put the conditions. If this sum is less than the target, so what we can do, we can just like if it is less than the target, so we can just move this left pointer ahead. And else if this sum is greater than the target, then we can just take the right pointer and move it back. Okay. And else will be the only condition where this sum will be equal to the target. So we will have to just maintain a resultant vector here. So we can just take a vector of vector int, okay, in which the quadruplets will be stored. That will be vector of vector int, and that will be equal to the result. Okay. So once we have taken this, now we can just take this result. So we can just push back that nums of I, comma nums of j, comma nums of left, and comma nums of right. These 4 values will be inserted inside the resultant. Okay, now after this, what we have to do, as I have already told, firstly we will be putting these left pointer values and the right pointer values inside. We will just take the 2 values, or the 2 variables, we can say, that we will just take the nums of left, and in one right variable we will take nums of right. We will just move on the values, the left pointers, the right pointers, till the values are same as the previous ones. We will just first of all check if this left is less than right or not, and if it is the case, then we can just take this, like again for that we will have to check if it is equal to the L value or not. If it is the case, then we can just take this left pointer and we can move ahead, because we do not want the same values. And so if this left is less than right, okay, this condition must be true. And if this nums of right is equal to this R value, then I can just move this right pointer back, because I do not want the same values. Okay. And once it is done, we can just come at the end, and we have to return this result. We'll return it. So this we have done here, and yes, we have already taken this input. This is the approach which we have written, and now let's just review it if it is going fine or not. So we have just taken the result here, in which we will be returning the output, and here we have just sorted the array, and then we were, see, because of the foursome problem, we have to have the 4 values, so at least 3 values must be there after it. and we have just checked the condition if the same fixed value is there or not, and this will be running from I plus 1 and going till, okay, after this at least two values should be there, so it will be going till like n minus 1, n minus 2 till n minus 3. Okay, so that will be less than n minus 2. And yes, for this also we have checked the condition, and yes, these are the pointers, and then we have just solved as the two sum problem using two pointers. So let's just run it and see what the output is. Again the six quadruplets will be there, the unique ones. Yes, we can see here the six quadruplets are there, which are the unique ones. Now let's just analyze the time and space complexity for this. So here we can see that first of all the sorting is done, so n log n will be the time complexity as of now, and the two loops are used first of all, so O of n square will be the case. And yes, inside this one while loop is also there, which will, where the left and right pointers will be there, where left and right both the pointers will be moving once, like in the different directions, left from left to right and right from right to left. So once these are moved, and so yes, because of which the uh, O of n will be the kind of operations taken inside these two loops. So the overall time complexity will be O of n cube. Okay, plus we can take n log n also, so we can see the overall time complexity is O of n cube. And now talking about the space complexity, so again the resultant vector is only used in order to return the result. That will not be considered inside the complexity analysis, but if we are considering the like sorting stack while the sorting is done, so like with the help with the with considering of that sorting stack, so that will be log n, otherwise the extra space required is constant only. So the time complexity overall in this case is O of n cube, and the space complexity is constant. So this is the pointer based like the optimal pointer based solution for this particular problem. This is all about this problem, and now in the next video I will be solving the k-sum problem, which will be a kind of generalized version of all the sum problems, because as we are using the different loops here every time based on the problems like 2 sum, 3 sum, and 4 sum, like we will have to consider that what number of loops we have to use. But in the k-sum problem, when we will generalize it, we will come to know that every recursive call is a kind of loop in which we will be solving that particular in which the recursion will just move on until that particular k-sum problem will not be converted into a 2 sum problem, because we already know that how we have to solve the 2 sum problem. So with the help of recursion we will just go on and just solve with the help of recursion until it reaches to the base problem, the 2 sum problem that we can solve by ourselves. So that's all for this particular video, and we'll meet with the next video. Till then, keep learning, keep growing. This is Aditya Pataria signing off. Thank you.